So let's do the integral of 1 over x times the square root of 1 minus x. We can try substituting u equals 1 minus x, which would turn the integrand into negative 1 over square root of u times 1 minus u, which allows us to do another substitution, v equals the square root of u, which would clean up the expression nicely, but I don't really want to do that. I'd like to just substitute u equals square root of 1 minus x from the start, which actually works out very nicely. So if we substitute u equals the square root of 1 minus x, then du equals negative 1 over 2 times the square root of 1 minus x dx. We would like to get an expression for dx entirely in terms of u, so the first thing we should do is multiply both sides of this equation by negative 2 square root of 1 minus x to get dx equals negative 2 times the square root of 1 minus x du. And since we let u equal the square root of 1 minus x, we can rewrite negative 2 square root of 1 minus x du as negative 2u du. We would also like to get an expression for x entirely in terms of u, since we have an x in the denominator of the integrand. So if we square both sides of the equation, u equals the square root of 1 minus x, we get u squared equals 1 minus x, and this implies that x equals 1 minus u squared. Alright, so if we substitute this back into the integral, this becomes the integral of 1 over parentheses 1 minus u squared times u times negative 2u du, since the x becomes 1 minus u squared, since we worked out that x equals 1 minus u squared, and the square root of 1 minus x becomes u, since we let u equal the square root of 1 minus x, and dx is replaced by negative 2u du, since we also worked out that dx equals negative 2u du. I'm going to do a few things now. I'm going to first bring out the constant of 2 outside the integral as a constant multiple, and the u in the denominator and the u in the numerator also cancels out. I'm also going to distribute the negative sign into the 1 minus u squared term in the denominator, which would make it u squared minus 1. So the denominator is just u squared minus 1, since the u term in the denominator already canceled out with the u term in the numerator, and the du stays the same, so this just becomes 2 times the integral of 1 over u squared minus 1 du. I'm also going to factor the denominator and rewrite this as 2 times the integral of 1 over u plus 1 times u minus 1 du, and what we need to do now is to use partial fractions to rewrite the integrand as a sum of 2 smaller fractions. So here's how we do the partial fractions for 1 over u plus 1 times u minus 1. We need to rewrite this fraction in the form a over u plus 1 plus b over u minus 1, where a and b are constants, since the denominator of the original fraction consists of distinct linear factors. So if we set this equation and multiply both sides by u plus 1 times u minus 1, we end up with a times u minus 1 plus b times u plus 1 equals 1. If we plug in u equals 1 into this equation, we get b equals 1 over 2, and if we plug in u equals negative 1, we get a equals negative 1 half. So a equals negative 1 half and b equals 1 half. If we plug this back into the right-hand side of the equation, we get 1 over u plus 1 times u minus 1 equals negative 1 half over u plus 1 plus 1 half over u minus 1, which simplifies to negative 1 over 2 times u plus 1 plus 1 over 2 times u minus 1. So we can rewrite 1 over u plus 1 times u minus 1 as negative 1 over 2 times u plus 1 plus 1 over 2 times u minus 1, which is a sum of 2 smaller fractions. Alright, so this means we can rewrite the integrand as negative 1 over 2 times u plus 1 plus 1 over 2 times u minus 1. If we multiply the constant of 2 back into the integrand, we end up with the integral of negative 1 over u plus 1 plus 1 over u minus 1 du. We can integrate this term by term, and the integral of negative 1 over u plus 1 is negative ln of the absolute value of u plus 1, And the integral of 1 over u minus 1 is ln of the absolute value of u minus 1, and we need to add the constant of integration c. So this becomes negative ln of the absolute value of u plus 1 plus ln of the absolute value of u minus 1 plus c. We originally substituted u equals the square root of 1 minus x. So if we substitute this back in for the u, we get negative ln of the absolute value of the square root of 1 minus x plus 1 plus ln of the absolute value of the square root of 1 minus x minus 1 plus c. So the integral of 1 over x times the square root of 1 minus x is negative ln of the absolute value of the square root of 1 minus x plus 1 plus ln of the absolute value of the square root of 1 minus x minus 1 plus c.